Scientists this week think they can explain why the fastest stars in our galaxy, that's stars going at 600 to 1,000 kilometres per second, are only spotted in one part of the sky, the constellation of Leo, and it's down to their explosive origins. Douglas Boubert is a second-year PhD student at the University of Cambridge, and he and his team used a computer model to try and work out what was going on, as he explained to me earlier.
The reason I think they are only appearing in one part of the sky is that they're coming from a dwarf galaxy, a galaxy orbiting our own called Large Magellanic Cloud. So what we think is that these stars are being born in binary stars in this dwarf galaxy. So there's two stars orbiting each other, and then one star ends up exploding and the other one gets kicked out. Now that can be like hundreds of kilometers per second. So the scenario I'm thinking is there's a dwarf galaxy flying past our own galaxy. These stars are being kicked away by their companions and then leaving that dwarf galaxy, and are then flying up through the Milky Way to where we see these very fast-moving stars.
Oh, right, these two stars are sort of dancing around each other at very high speeds in a galaxy that's already moving very fast. One of the stars explodes, that shoots the other star completely out of the galaxy.
Yes, exactly that. If you're ejecting stars from a galaxy, it's like a cannon that's firing in a random direction. But ejecting stars from this dwarf galaxy is like mounting that cannon on a train. Suddenly these stars are being kicked much faster because they're starting such a high velocity. And the fastest stars are being ejected in the same direction the galaxy is moving.
So tell me about the simulation. How did you crunch the numbers to work out that this is indeed what's going on?
We started with something which the observers tell us, which is the number of stars that are formed per year in this dwarf galaxy. We know how likely a star of a certain mass is to form, and we know how likely that star is to have a companion. So drawing random stars sort of fill up our bucket of stars per year, you get an idea of sort of what numbers of different stars are forming in this galaxy. You can then simulate the evolution of the stars together, and that tells you which of your stars you've randomly picked are going to end up ejecting a star. And then you need to take these ejected stars and their velocities and when they're kicked out and follow their orbits in this simulation of the gravity of the Milky Way and the dwarf galaxy interacting.
Is this problem solved now, or do we need any more data to sort of confirm that this is what's happening?
Well, I think it's definitely still just a hypothesis. I mean, before now, the idea for where these stars are coming from has been that they're coming from the centre of our own galaxy. So this is actually quite a big shift to imagine them not coming from our galaxy, but coming from an entirely different galaxy. This is actually the perfect moment to have made this prediction, because next year, the European Space Agency's Gaia satellite will be releasing an incredibly deep map of the entire sky, and it will definitely be going deep enough to see these stars if they exist. So our prediction is that between this dwarf galaxy and this clump of stars, there's a trail of thousands of these hypervelocity stars spread right across the sky.
Thousands of these things?
Yes.
Oh, wow. Are any headed our way?
Some will be.
Wait, what? Are they going to destroy our solar system then?
Probably not.
Probably.
Well, I mean, space is very big. And not only that, the gaps between the things that are in space are huge. It's like even when two galaxies collide, you actually never get individual stars hitting each other.
And these stars, I mean, why is it important to know where they came from?
Well, one of the reasons is that if you have stars which you know where they've come from and you know where they are now, you have a really good idea of what their orbit's been like, where have they travelled. And if you know that, you can start to constrain the gravitational field of the Milky Way. So if these stars had travelled all the way from the centre of our galaxy out to the outskirts of the Milky Way, you can use them to measure the mass of our galaxy. And people have done this before. So one of the controversial parts of this work is that we're actually saying that work is wrong because they aren't coming from the centre of our galaxy.
That was Douglas Boubert from the University of Cambridge.